Okay, so there's a big, nasty, ugly formula on the back of my cover page. It is actually taken from a proof that I did in a class, and I took a picture of it and decided it looked pretty neat, so I put it on the wall. And I want to explain where that comes from. And to do that, the first thing we need, it is the quadratic formula. It's an equation that's used most every day in college level math or higher. There's some calculus techniques that use it, but it's used to solve quadratic equations. And so in order to know how the formula is derived, the first thing you have to know is how to complete the square and why we complete the square. So we need to know how to complete the square. So we have a square. And let's say it is formulated from two distances. We know that that this is x, this distance is x, and this distance is a. So that would give this distance a, because it's a square, and this distance is x. Okay, so if I want to find the area of this square, the length is x plus a, and it's a square, so it'd be x plus a squared. So let's look at the little parts that are inside this square so that we can find the area. Well, this little part here, this square here, is a times a, which is a squared. And this rectangle here is a times x, which is ax. And so is this area. This is a times x, which is ax. And this side is x, and this side is x, so this area here is x squared. So we can say that x plus a squared is equal to x squared plus 2ax, which is one ax here and one ax here, plus a squared. Okay, so this is a formula for finding the square of a binomial. This is a binomial, which is a polynomial with two terms, and when you expand it out, you get this. Okay, so why do we do that? Well, the main reason we use this is so that we can solve quadratic equations by going back to this format. So in other words, let's say I have x squared plus 4x plus 4 is equal to 0, and I want to solve for the x that makes this true. Okay, well, I know that if I take half of this and square it, what is half of this term? Well, it's 2a, right? Half of this term is 2, and if I square 2, I get 4. So this term here is really x plus 2 squared. Okay, I took half of this term and squared it. Okay, if I expand this out, if a is 2 in this case, these two are equal. Now I can take the square root of both sides. If I take the square root of both sides, I get that x plus 2 is equal to plus or minus 0. Well, plus or minus 0 is 0. In this case, that's x equals negative 2. So let's plug in negative 2 into this equation. We'll have negative 2 squared plus 4 times negative 2 plus 4. What do we get? Well, this negative 2 squared is 4 plus 4 times negative 2 is negative 8 plus 4. And 4 plus 4 is 8, and 8 minus 8 is 0, which is what we wanted. We wanted the x that made this 0, and that is x equals negative 2. Now, this case is a rather easy case. Let's try one that's a little harder, that makes a little more sense. Why would we do this? We could just factor this and solve it and get x equals negative 2. Let's find one that's a little harder. So in this case, let's say we have x squared plus 10x plus 3 is equal to 0. And I want to know the x's, what x makes this true. Okay, so the easiest way to solve this is by a method called completing the square. So I'm going to set this up to be x squared plus 10x, and I'm going to take 3 from both sides. So if I take 3 from this side, if I take this 3 from this side, I'm left with nothing. If I take 3 from 0, I have negative 3. Now, what I have is this part of this square without this box. I don't have the a squared. I have the x squared plus 2ax. Okay, I have x squared plus 2ax. So I want to add half of this to both sides. So if I add half of this to both sides, I get x squared plus 10x plus half of this squared. Well, what is half of this squared? Half of 10 is 5. 5 squared is 25. But I can't just add it to one side. I have to add it to the other side. Negative 3 plus 25 is 22. Okay, now I have a perfect square over here that I can factor. And it's really easy to figure out what you squared. Well, the number that we squared is the number that goes right here. So if I expand out x plus 5 squared, let's do it. X squared plus 2ax, which is 10x, plus this term squared. These two are the same. And then I have 22. Okay, now let's square root both sides. Take the square root of both sides so that I can solve for x, because I can find the square root of this. The square root of this is x plus 5, and the square root of this side is plus or minus 22. So now, to solve for x, we take 5 from both sides. If I take 5 from x plus 5, I'm left with x, and I'm just going to add it in front here. And this is actually a square root. So x, in this case, is negative 5 plus or minus the square root of 22. Okay, can we prove that? Sure. If I take negative 5 plus or minus the square root, let's just use plus, because it's plus or minus, squared, plus 10 times negative 5 plus the square root of 22, plus 3, I should get 0. Okay, let's square this. This is the hard part to square. Okay, so we're going to use the same formula. We square the first, which is 25, multiply the two together. Well, multiplying the two together, the only thing you can get is negative 5 times the square root of 22. So negative 5 times the square root of 22 plus negative 5 times the square root of 22 is negative 10 plus times the square root of 22 plus, well, the negative square root of 22 squared is just 22. And then we'll distribute this here. 10 times 5 is negative 50. Okay, so I'm just distributing this 10 here, plus 10 square roots of 22 plus 3. Now what should this add up? It should add up to be 0, right? Let's see if it does. Negative 10 square roots of 22 and negative 10 square roots of 22, those two cancel. Those two positive and negatives cancel. 25 plus 22 plus 3 is 50. 50 minus 50 is 0. So that works. And it also works for the negative. I'm not going to do it for the negative. But this is why you complete the square. But where does it apply to the quadratic formula? The quadratic formula says, hey, I don't want to do complete the square all the time. I just want a formula that says, hey, what's the... for any number, ax squared plus bx plus c is equal to 0. For any a, any b, any c, is there one formula that I can use instead of having to use the complete the square every time? And the answer is yes. It's the quadratic formula. Well, where does that come from? Well, it comes from completing the square on this equation. Okay, so let's do that. So notice that when we complete the square, this coefficient is 1. So this coefficient is 1. So the first thing we need to do is divide everything through on this equation by a, so that we have this coefficient, which is the number in front of x squared, as 1. So if I divide everything through by a, I get, well, a divided by a is x squared, plus b divided by a, x, plus c divided by a, and 0 divided by a is 0. Okay, so now we have this. Now we had the first two terms on one side only, so we took this term and brought it to the other side by subtracting c divided by a. Now, when we did it this way, of course, this looked a whole lot easier because this is just 3, but c over a is just a number just like 3. It could be 9 over 3. C could be 9 and A could be 3. 9 over 3, either way. So let's do that. Let's just take this as a number and subtract it from both sides. So we'll have x squared plus b over ax is equal to negative c over a. Okay. Now I need to complete the square. We had these two terms. Now what did we do? We added half of this squared to both sides. Well, half of b over a is b over 2a. So we're going to add half of this squared. Let's square it and we'll get b squared over 4a squared. So we're going to add b squared over 4a squared to both sides. So we'll have x squared plus b over ax plus b squared over 4a squared is equal to, now instead of adding it on this side, I'm going to put it in front. I'm going to have b squared over 4a squared plus negative c over a squared. Okay. Well, what is this? This, we had to complete the square. Well, what did we square on both sides? We squared b over 2a. So this is going to be x plus b over 2a squared. These two are the same. Let's show that. Well, the first term squared is x squared. This term squared is b squared over 4a squared. If we multiply these two together, we get xb over 2a. And if we double that, all it does is get rid of the 2 in the bottom, because double a half is 1. So if we multiply these two together and double it, we get b over ax. Okay. What's on this side? Well, in order to add these two, we need to have a common denominator. And this is c over a, not c over a squared. We need to have a common denominator. Okay, so we can multiply both sides by a, and we can multiply both sides by 4, and now they have a common denominator. They both have 4a squared. So what's in the numerator? B squared minus, because the sign is negative, 4ac divided by 4a squared. Okay, so what's the next step? Well, we need to solve for x. So the first thing we need to do is undo this square. So to do that, we take the square root of both sides. So if we take the square root of this side, and we take the square root of this side. So the square root of this side, it has a variable. So we're going to call this x plus b over 2a, because the square root of a square is just what's inside there. What's on this side? Well, on the numerator, we're going to have plus or minus the square root of b squared minus 4ac. And what's in the denominator? Well, both of these are perfect squares. The square root of 4 is 2, and the square root of a squared is a. Now we can solve for x by taking away b over 2a from both sides, right? That's easy because they have the same common denominator. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And there is the quadratic formula. So now let's check it and see what, see if this works. So we had, I'm going to rewrite this problem that we had before and see if we get the same answer. So if we have x squared plus 10x plus 3 is equal to 0, we said that x was equal to negative 5 plus or minus the square root of 22. Okay. So here's our quadratic formula. Okay. This applied when this is a x squared plus bx plus c is equal to 0. So let's plug in the a, b's, and c's. Okay, so we say that x is equal to negative b. Well, negative b is negative 10 plus or minus the square root of b squared. B squared is 100 minus 4 times a. A is 1 and b is 3. All divided by 2a. 2a, well, a is 1, so 2a is 2. Alright, that doesn't look the same, does it? These two don't look the same. Yet. Well, 10 divided by 2 is 5, so we're starting there. But what about this guy here? What's underneath the square root? Well, x is equal to negative 10 plus or minus, well, what is this? This is 100 minus 12, which is 88. So we'll have the square root of 88 over 2. Still doesn't look right, does it? But 88 is 4 times 22, and the square root of 4 times 22 is negative 10 plus or minus 2 times the square root of 22. Because the square root of 4 is 2, I can pull that out. And all that is divided by 2. So indeed, this is equal to negative 5. And you can't see that on the camera very well. Negative 5 plus or minus the square root of 22, which is what we have here. They're the same. So this is how you derive the quadratic formula and what it is used for. It is ugly, it is nasty, it is tough to teach and let people explain, understand what it means. But if you know how to utilize this formula and know how to complete the square, it makes algebra a whole lot easier. Thanks for your time. See you soon.